our society. Many researches shows that urban areas today are responsible for as much as 80% of carbon dioxide emission in the atmosphere, as well as the 75% of the total energy consumption. So therefore the energy management in urban areas seems to be very important. And practice shows actually the greatest savings of energy consumption can be achieved through the energy recovery of the existing building stock. Well, the question is what happened when we talk about the built heritage. Actually, in the process of protection of cultural built heritage, which represent the important aspect of the sustainability, as the culture is the fourth pillar of the sustainable development, it is necessary to carry out the energy revitalization of each building. And the problem is that some buildings are recognized as the important barriers of the cultural and historical heritage, so they are put in some kind of protection regime, and each of the protection regimes have a different requirements that must be respected. And because of that, in the process of deciding which measures of improving energy efficiency must be implemented, we actually have to consider that requirements that are different for different degrees of the buildings under protection. And our paper actually aims to rank the different already known indicators which are important for improving the energy efficiency using the mathematical method of analytical hierarchical process, and to point out which the measures are the most significant to be applied. When we talk about the managing of the built cultural heritage in Serbia, we must say that cultural heritage can be divided into two main groups, immovable and movable. And cultural monuments, which actually represent the architectural buildings of cultural and historical particular importance, are actually one type of the immovable cultural properties. And depending on their significance, they are divided into three categories. So we have in Serbia cultural monuments of great importance, and cultural monuments of exceptional importance. And this categorization, in the next slide, you can see the review of the requirements that are set for this 3 degree of protection regime. And actually these requirements shows us are in some kind of relation to the different obstacles related to the interventions that can be or cannot be done into the interior construction or exterior facade interventions, as well as change in facade articulation, materialization, color, and so on. On the next slide, we actually try to summarize the already known indicators for improvement of energy efficiency. We divided these indicators into two main groups. First groups represent the indicators related to the improvement of the thermal and energy properties of technical systems in the buildings, as well as the possibility of using renewable energy resources, while the second main group represent the indicators which are related to the improvement of thermal properties of the facade envelope and internal structure of the building. And these two groups have appropriate subgroups, sub-criteria. When we talk about the improvement of the technical systems, we distinguish 6 different sub-criteria. So we have the installation of the valves for thermal regulation, use of a chimney for the ventilation, automatization of all technical systems, regulation of water consumption, changing the type of energy source, and the use of energy efficient lighting and home devices. When we talk about the renewable energy sources, we can use the solar energy, geothermal energy, biomass, or wind energy. Then further, when we talk about the thermal zoning in the buildings, it can be linear and vertical, as well as concentrated. And the improvement of thermal facade envelope can be carried out using the thermal insulation of the facade walls, or thermal insulation of the roof, as well as the changing the glass of the openings and joinery, and as well as the introduction of double facades, greenhouses, sun protection systems, greenery, and use of many different kinds of modern energy efficient materials. And when we talk about the improvement of thermal properties of the interior of the building, we distinguish the internal thermal insulation of the walls, ceilings, and floors, then use of interior walls with collector function, and introduction of floor heat storage. And a couple of words about used method. So, analytical hierarchical process method represents one kind of multi-criteria technique, which is based on the interpretation of one complex problem through a hierarchy. So at the top of the hierarchy we have the goal of our research, while the criteria, sub-criteria, or different alternatives are at the lower level. And this method have 5 stages. So first one represents the structuring of the problem, while the second one is the most important one. It means collecting data and forming a pair-wise comparison matrices. And these comparison matrices are made by comparison between each 2 elements of each level of the hierarchy, using the appropriate scale which is present through this table. So following the ranking method, the decision makers actually assign weights to each pair, and it means that they actually put some measure of how much one indicator or criteria is more important than the other ones. On the next stage, we have the determination of the relative weights, assessment of relative weights, and finally the solution for our problem. In order to check the consistency, we use the appropriate indexes, index of the consistency and the ratio of the consistency. And in the next slides you can see the results. So first we have the weight coefficients for the 2 main groups of the criteria. In the first column actually represents the results for the cultural monuments of the exceptional importance. The second one represents the results for the cultural monuments of great importance, and the third one actually represents the third category of cultural monuments. Second table represents the weight coefficients for the sub-criteria of the group of the technical systems, while the third sub-criteria group of the thermal properties. And so on, we have the results for the technical systems improvement, then the implementation of the renewable energy sources. Further, we have the results of appropriate weight coefficients for the sub-criterion thermal zoning, then for the improvement of the thermal facade envelope, and for the improvement of the interior of the building. And the conclusion is actually represented through this final ranking of all of the criteria, and ranking is done in relation to the first category of the cultural monuments of the exceptional importance. And we can say actually that internal thermal insulation of the walls, ceilings and floors, as well as the use of interior walls with collector function seems to be most important criteria for all 3 groups of the for all 3 degrees of protection regime. Then when we talk about the first degree of the protection, actually the use of a chimney for ventilation and biomass for heating and regulation of water consumption are actually quite important measures too. While for the second and the third one, use the thermal insulation of the roof and introduction of floor heat storage seems to be important too. And finally, I can say actually this research shows us that this kind of multi-criteria technique can be successfully used in a process of deciding which measures for improvement of energy efficiency can be used in the field of the cultural built heritage. And finally, for our further researches, we can actually compare these results with the results of ranking the criteria for improvement of energy efficiency of existing buildings which are not under the protection regime. That's all. Thank you.